we are going to revise circles for our board examination. That is, before revising this chapter, you should know how much important this chapter is. This chapter has, on an average, 8 marks, maximum 8 marks weightage will be there, minimum 3 marks weightage will be there. Last year they asked this chapter for 8 marks, and for the past 5 years, all the questions are directly NCERT book questions. It's a direct question. Like 2018 they asked direct textbook theorem 10.2, and 2019 direct NCERT textbook question. We have 2 exercises, right? In that, from the second exercise they asked 1 question. Okay, so that kind of things. 3 mark, minimum 3 marks we can expect, maximum 8 marks will come. Last year, so most of the questions are textbook questions. They are really important. Okay, now we'll get into the concept. Here, circle means the circle will have a center and the radius we have it, and we have a relationship between line and the circle. So there is a straight line. This line has 3 possibilities. Either it can touch the circle at 1 point. Whenever they say touch, it means 1 point. Whenever they say intersect, it means 2 points. Okay, intersect means it is passing through. Touch means common point, 1 point. So if a circle and a line has only 1 point in common, we call that line as a tangent to a circle. This is non-intersecting line. This is tangent. Suppose that line is intersecting the circle, then by this time it is called as a secant. How do we call it? Secant. Instead of this line, there is a line segment which connects any 2 points on the circle, is called the chord of a circle. Okay, got it? A circle can have infinite number of tangents. Like it may have infinite number of tangents. Okay, whenever we take the tangent situation, that point, that one common point, I said no. That common point may be on the circle, may be outside of the circle, may be inside of the circle. If a point is inside the circle, there will be no tangents possible. Is it or not? Because as per the definition, it should have only 1 point in common. It is inside. It will intersect only. It will not have touching. It will not be touching. So if the point lies on the circle, it will have only 1 tangent passing through it. At a point B, we have only 1 tangent. Okay. Suppose a point C lies outside. This is called the exterior point. A is interior point. This point on the circle. From the exterior point, we have 2 tangents possible. Okay, that is it. This is about tangents, and we are coming about chord. Chord is connecting 2 points of a circle, and among that, if that chord passes through a center, then the largest chord is called as diameter. The largest chord of a circle is diameter. Likewise, how many diameter a circle can have? Infinitely many diameters. Okay, just like how many secants will be there? Infinitely many secants will be there. Okay, chord also we can draw infinitely many chords. Based on that, in 9th class we have studied some results. Okay, now we have 2 theorems. The theorem 10.1, which is really important. You are aware of the 10.1 theorem? Sorry. The theorem 10.1 states that the tangent at any point of a circle is perpendicular to the radius at the point of contact. You are aware of this theorem? How to prove this? See, yes, good. Circle we have to consider. At a point, this is a center, this is the radius. If you take other point, means this is O, P, Q, R. This OR is greater than OP. That means OQ plus QR, which is greater than OP. If you take any other point on this line, that would be greater than this OP. This is the smallest distance. the smallest distance between the point and the line is the perpendicular distance only. That is why we conclude that this is perpendicular. Okay, and the theorem 10.2 is about length of the tangents drawn from an external point to a circle are equal. So there is a circle. From the external point we are drawing two tangents. Okay, this length of the tangent should be equal. Before that you should know how to write the given statement, to prove statement and all. That and all you know. Let us consider a circle with the center O, and let P be the external point and PA, PB be the tangents drawn from P. Okay, then we need to prove PA is equals to PB. You know how to prove this? That's what we need to prove. Yes. You have to connect these two first. You can prove that using congruency. Okay, this is the common side, this is the radius, and any other thing. Yes, RHS. Here 90 degree we'll put. Now only we have seen radius is perpendicular to the tangent. Okay, using RHS congruency, these two triangles are congruent. So we have PA is equal to PB by CPCP. That's all. And two concentric circles of a chord, then they bisected at the point of contact. Two concentric circles with the center. This is a chord for the big circle, tangent for the small circle. If you connect this is the center. Concentric circle has same center. So this is 90 degree. And in 9th class we have studied that if a line drawn perpendicular from the center, it will bisect the chord. When you see this is the larger circle, it is a chord, a line drawn perpendicular from this. So the larger circle, it acts like a chord, then it bisected. That's all. That's what we need to prove here. You want me to write the exact proof, full proof? You know this, right? See, concentric circle means it will have same center. Okay, and this AB is a tangent for this small circle. Let me name this C1, this is C2. Okay, so C1 circle, AB is a tangent. For C2 circle, the circle C2, AB is a chord. Okay, we use this tangent perspective to figure out here 90 degree will be there. According to C1, here 90 degree. Just because it is 90 degree and it is drawn from the center. Now look at C2. Perpendicular drawn from the center, bisects the chord. That's all. That is what they gave in the statement, that prove that two concentric circles, the chord of the larger circle which touch the smaller circle is bisected at the point of contact. That is it. Okay, and then this another theorem, that is example 2 actually. We are aware of this? Yes. You know that, right? That's an important question. This year we may expect this question. Okay. And then this example 3. We solved using Pythagoras theorem. Remember? In example 3. Center. And this is the point P, this is TP, TQ. Okay, and we need to find the length of TP. This length we have to find. It is given that 5 cm is the radius, and the length of PQ is 8 cm. Totally PQ 8 cm. Now this is the perpendicular. Here we have 4 cm. Okay. You remember we took here x fully. What is it? Here we took x, and then the total length. No. Okay. This is radius now. Then we'll take this is x we'll take. Okay, and then use Pythagoras theorem in this two triangle. That's all. Okay, here x, here y we can take, man, don't bother. here x, here y we can take. Okay, totally we can write x plus y whole square. How to find x? See, when you equate this, what we may get using Pythagoras theorem, in this triangle itself we can find y. Is it or not? After finding y, it is fully x plus that y. Here it is right angle triangle again. These two sides are known. This side is unknown. Then we can write it. That's all. Okay. You want me to prove this? We already proved this, man. Okay, and then this exercise 10.2, the first few questions are purely an application of what we learned here, but here this structure, you remember, these two angles are supplementary, these are supplementary, and these two angles are bisected. Suppose here 60 degree means this is 30, this is 30, like this it will be bisected. Okay, by using that you will be seeing that first three questions of this, and then you want me to, shall we discuss the first three questions of exercise 10.2? Yes, read the question and see by yourself. Okay, you can understand, right? Okay. Now, look at the fourth question. Prove that the tangents drawn at the end of the diameter of a circle are parallel. Tangents drawn at the end of the diameter of a circle are parallel. So here, let us consider a circle with the center O. Let AB be the diameter of the circle. We have to prove that the tangents passing through A and B are parallel to each other. Simply see this, apply this theorem 10.1 here. So OB is the radius and this is a tangent. We name it as PQ and this will be RS. Let it be. So this radius, this is tangent. Here we have 90 degree. Is it? Because radius is perpendicular to tangent. Likewise here also, this is the radius and this is a tangent. Here we have 90 degree. That's all. And we have an axiom called alternate interior angle axiom. You remember? When alternate interior angles are equal, then the lines are parallel. 7th class, lines and angles we studied. If two lines are parallel, you remember, alternate interior angles are equal. And then angles on the same side, co-interior angles are supplementary. When the two lines are parallel, these results we studied. And the reverse of this, if co-interior angles are supplementary, then these lines are parallel. If alternate interior angles are equal, then these lines are parallel. Okay, it's a reverse result. It's called by alternate interior axiom. Then alternate interior angle axiom, we have proved that RS is parallel to PQ. That's all. That is the minimum concept. And then this question number 5, prove that perpendicular at the point of contact to the tangent to a circle passes through the center. Perpendicular to the point of contact we are drawing a perpendicular to the point of contact. Okay. It passes through the center, we have to prove. Okay. So, suppose we are drawing a perpendicular. It is from O dash. It's a perpendicular. It's not about radius. As we know, this radius is perpendicular to the tangent. If you put another perpendicular also, this Q will be merging with O. Is it or not? Is it or not? Already we have OP is perpendicular to AB. Suppose we decide that it is not passing through the center, it passes through some other point. Then automatically what it will come? QP is perpendicular to AB. Then what it means? This OQ coincide each other. Then only it is possible. Okay. That is all. And then question number 6. The length of the tangent from a point A at a distance 5 cm from the center of a circle is 4 cm. Then find the radius of the circle. Easy. You don't understand the question, do you? Read the question once. Okay. We have drawn a tangent. Length of the tangents from the circle. Okay. It is 5. Oh, radius is 5. This is 4. Oh, sorry. Read the question again. Come on. We have to find the radius, is it? Sorry. Length of the tangents at the distance 5 cm. So, at a distance 5 cm. Now, this is 5 cm. Radius is, tangent length is 4 cm. Then radius we have to find. We know that these two are perpendicular. Then, using Pythagoras theorem, this is 3 cm. That's all. But proper steps you have to write, remember. Okay. Don't you understand this? Okay. Have you understood this? You want me to explain this once again? Okay. Next, 7th question. Two concentric circles of radius 5 cm and 3 cm. Find the length of the chord of the larger circle which touches the smaller circle. We have seen this concentric situation previously. Larger circle, smaller circle. This line touches this. This is the center of both circle. Okay. And the radius of the smaller circle is 3 cm. Is it? Radius of the larger circle is 5 cm. Then this chord length we have to find. Remember, now only we have seen an example. How to find, can you say? Come on. This is right angle triangle. Using Pythagoras theorem, this is 4 cm. Okay. Then this is bisected, you remember? They asked the length of the chord. Then total length of the chord is how much? 8 cm. That is it. So far we have seen they are very easy question. It is like Lay's chips. Simply will bite, crush, move on. That's all. In this, do you have any doubts? No. So these questions could be asked in the 3-mark questions. Okay. And the question number 8. A quadrilateral ABCD. I need to ask you that. What difficulty you find in here? Doesn't it feel easy or is it feeling heavy? What orderly? Oh, that 8th question you are talking about. 8th question I'll say, man. Don't bother. See? Quadrilateral ABCD is drawn to circumscribe a circle, then prove that, which is nothing but, oh, this is not at all a circle first of all. And it is A, B, C, D, P, Q, R, S. Okay. We have to prove that AB plus CD is equals to AD plus BC. This results we may be using in MCQ also. Whenever a quadrilateral circumscribes a circle, sum of their opposite sides are equal. Okay, that is what this we can take away from this. They may give any one side, any two sides of a triangle, and they may ask us to find the other side. Like 2 to 3 sides they may give, one unknown they'll keep. Now to prove this result, we will be using that. You know this, right? A is an external point and AP and AS are tangents. Is it? So those results we have to write. So A is an external point. We have AP is equal to AS and PB is equal to QB. And then here SD is equal to RD. And then CQ is equals to RC. This like as per our rules you can write. But while writing, you see, take this AB. You have to start from any one side, right? So I am starting from the LHS. AB plus CD I am going to write. So AB can be written as what? AP plus PB. Is it? Is it or not? And then plus CD can be written as CR plus RD. Okay. Now these two things, these four things we have written. Clear? We should get the sides of AD. You don't bother, look at the side AD. These two things are there, right? Who are they? AP and RD. AP is here, RD is here. Replace their corresponding pairs. That's all. First and last. Okay. Okay, yeah. From this side we should reach here. From this side we should reach here. Is it or not? I took AB plus CD and this AB as two pieces I written. Here also two pieces I written. Is it? Now by replacing accordingly, instead of this piece what we can write? AS. Is it or not? Tangent from external point. Instead of this RD we can write DS. So we may get AS plus SD. What is it actually? That's all. Or if you written this correctly also, you don't bother, just don't mind. After writing this, directly write AS plus SD. Don't write directly answer AD plus BC. Okay. You write the pieces of this sides, these two sides. AS plus SD. Simply I written. I didn't check this and all. Okay. Really if you feel difficulty, but it is really easy. Instead of AP, I wrote AS. Instead of RD, I wrote SD. What is it? Pieces of AD. Similar way, can you suggest how this could be done? Instead of PB, what we can write? Mark in the diagram itself. Okay. Instead of PB, we can write BQ. That's all. Did you bothered about whether these equations holds or not? We wrote what are all equal. We splitted them into pieces. And instead of these pieces, I wrote the opposite sides pieces. That's all. Okay. Clear? Don't confuse. If it's still confusing, just proceed in this manner. Clear? This like you can mark in the diagram also, not a problem. So these two grouped. Then what we got is AD plus BC. Alright. Next, after 8th question, directly see the 11th question. We did this already, remember? Read the 11th question, come on. Parallelogram circumscribing a circle is a rhombus. Parallelogram is what kind of polygon? Quadrilateral. Quadrilateral circumscribes. Same proof. Is it or not? Is it or not? Now we should apply the properties of parallelogram and we should say it is a rhombus. What makes a parallelogram a rhombus? All sides are equal. Already in the parallelogram, opposite sides are equal. Then what it is enough to prove? Same proof follows, man. Since ABCD is a parallelogram, we have AB is equals to CD and AD is equals to BC. Okay, clear? It's already opposite sides are equal. If these two pairs are equal, it is enough to prove these two sides AB and AD are equal is enough. Then all the four sides will become equal, is it? Okay, now bring this result. We have from 1, we have this AB plus CD is equals to AD plus BC, isn't it? What do we need to prove here? Adjacent sides are equal. Okay, so instead of CD, I'll be replacing CD with the AB, that is 2AB. Okay. Likewise, here suggest one, we can write 2BC also, 2AD also. What we can write? Both will give us the result. 2AD. Because BC is equal to AD, just because it is a parallelogram, otherwise it is not applicable. Okay. Then 2 cancelled, we have AB is equal to AD. That AD is already equal to BC. Our AB is already equal to CD. So all the four sides are equal in a parallelogram. That is what? Rhombus. That's all. Okay. So 8, 11 are same questions. That 11th question is some extra steps with the 8th one. Got it? And then look at the 9th question. Will I erase this? You want to note this? You want me to explain this once again? All right. Okay, good. Next, read the 9th question. Figure 10.13, isn't it? X dash, Y dash. Okay, this is the center and this is X, this is Y, this is P. And we have a tangent. Okay, that's all. Here, Q. XY and X dash Y dash are two parallel tangents to a circle with the center O and another tangent AB, point of contact C, intersecting XY at A and X dash Y dash at B. AOB is, we have to prove that AOB is 90 degree. Okay, where is B? Here B. Where is A? Here A, hiding somewhere. Okay. Okay. So we need to prove angle AOB 90 degree, which is very easy actually. Okay. The thing is, we are going to draw a line. We mark it as C. And we are going to prove that these two triangles are congruent. Let me mark the angles like 1, 2, 3, 4 like I am marking. Okay. Using linear pair, we are going to solve this. If we can able to prove sum of 3 and 4 is equal to 1 and 2, not like that. 3 is equal to 1 and 2 is equal to 4, it can able to prove means, using the linear sum property, we will write 1 plus 2 plus 3 plus 4 is equal to 90 degree. Instead of 3, we replace 1. So 2 times 1. Instead of 4, we replace 2. 2 times 2. It will become 2 times 1 plus 2 times 2 is equal to 180. Then 1 plus 2 is equal to 90. That is what. But before that, we need to prove 1 and 3 are equal. To prove that, look into that which triangle they are part of. They are part of AOC and AOP. This triangle AOC and triangle AOP. Using congruency, we are going to prove it. Look at this. OC is equal to OP. Why? Radius. And we have tangents. PA is equals to. Oh, no. See? Sides of this triangle only should be written here. Okay. It's not PA. It's AC is equal to AP. They are tangent from the external point of a circle. And common side OA. OA is equal to OA common. Yes, ask. Tangents from an external point. We proved theorem. Like the sides of this triangle only should be written below. I was about to write AP is equal to AC, but that is wrong. We are supposed to write only the corresponding sides of a triangle only. Okay. So from this, what we can conclude is this triangle AOC is congruent to triangle AOP. That makes angle 1 is equals to angle 3 by CPCT. And then similarly, we don't need to prove the same thing for these other two triangles. Simply you can write similarly. No, there is no SAS applicable. 90 degree if you take means SAS will come. SAS also will come, RSS also will come. Better go by SSS. Okay. What you are suggesting is here 90 degree, here 90 degree. Then if you take these two sides means that is SAS. If you take these two sides means that is RHS. Why confusion? Better take SSS. Okay. Don't think too much. And then here similarly we can prove angle 2 is equal to angle 4. And we have this angle 1 plus angle 2 plus angle 3 plus angle 4 is equals 180 degree. And instead of 3 we can write 1, that becomes 2 times angle 1. And 2 times angle 2 it will become. This 2 and 4. Instead of 4 we can write 2. That is equals to 180 degree. Then we have angle 1 plus angle 2 is equals 90 degree. That is nothing but angle AOB is 90 degree. Okay. Any doubts? Next, I put simply similarly. I don't need to write that once again. Okay. Yeah. Now, look at the 10th question. Prove that the angle between two tangents drawn from an external point to a circle is supplementary to the angle subtended by the line segment joining the point of contacts at the center. That means that is just a byproduct of this one. Okay. The line drawn from, sorry, not like that. Prove that the angle between two tangents drawn from an external point is supplementary. That is not one. That is not this one. This other one. And 13th question. Sorry, I said 11th. Sorry, 10th. It's 13th question. Look at the 13th question. Prove that opposite sides of a quadrilateral circumscribing a circle subtend supplementary angle at the center. Okay. That is exactly the extension of this question. This 9th question. As like 8 and 11 are extension. This 9 and 13 also extension. We should draw one more thing here. You noted down this? Okay. We should draw one more thing like this. A tangent can be drawn and these things can be erased. It's a quadrilateral, they say. Quadrilateral circumscribing a circle. Then angles subtended by the opposite sides are supplementary. Angles subtended by the opposite sides means this is one side, opposite side is this one. Is it? Sum of these two angles is 180 degree we have to prove. Okay. Okay. For that we are going to extend this line. We make it as CE. 1, 2, 3, 4 are 5, 6, 7, 8. Here you did one process, right? 1 is equal to 3, 2 is equal to 4. Same thing will be extending here. Similarly, 2 is equal to 4 and then 5 is equal to 6, shall we say? And 7 is equals to 8. Okay. And we use angle sum property again. What is that angle sum property? 1 plus 2 plus 4 plus angle 5 plus angle 6 plus angle 7 plus angle 8 totally equals to 360 degree. Got it? Just we extended the same thing here. Okay, 360 degree. And this can be paired as 2 times angle 1 plus angle 2. Okay. Likewise, this you paired means which pair you need? Everything in terms of 6 and 7 or 8 and 5. What do you need here? 6 and 7 should be. So 2 times angle 6 plus angle 7 shall we write? That is 360 degree. You take 2 out from this. We have angle 1 plus angle 2 plus angle 6 plus angle 7 equals 180 degree. Angle 1 plus angle 2 is nothing but AOB. Angle AOB plus here A, B, C already written here. Let me write, this is F we will take, and then C, D. Here also we should change accordingly. While writing we can change, not a problem. So this is F I wrote and this is COD. Okay, angle subtended by the opposite sides of a quadrilateral circumscribing a circle are supplementary. And this is not full proof. Similarly, we should write for the whole other side. That is angle COB plus angle AOD also equals 180. And this therefore statement should be, the question they given, right, prove that. Remove the sentence prove that, put therefore, that is our therefore statement. Okay, what is the therefore statement? Can you say? Therefore, opposite. That's all. Got it? Any doubts on this? These two are very, very, very important questions. Got it? 8 and 11. Once again. See, first question we proved that 1 plus 2 is 90 degree. How we proved? Using congruency. This is a construction we made. This is not given in the question. Okay. We made a construction that after making the construction, we have taken the triangles, these two triangles, and we proved 1 is equal to 3. Got it? Similar way, each 2 pair of triangle can be taken. If you are sticking on with the previous question means, leave this part. These two are equal, these two are equal. Using angle sum property, the linear sum, linear pair property, we added everything and we put 90 degree. That you understood, right? Similar way, we extending this for the other side of the quadrilateral also. There it is given the 2 lines. Here it is quadrilateral. That's all. Okay. And then the sum of these 2 angles is 90 degree we have to prove. That is, this 1 plus 2 already 90 degree. Similarly, we can prove 6 plus 7 also 90 degree. Yeah. When you add those two. And they are talking about the angle subtended by the opposite sides of a quadrilateral. That means sum of this angle and this angle. This angle they are talking about. So that is why I extended this proof for the other side. We proved other two pairs also equal. Fully angle sum I took. That is 360 degree. Or else you can take the other side also separately. Prove 6 plus 7 is equal to 90. Later we can prove. That's also one of the possibility. Okay. Clear? Any doubts? Okay. Now we complete the 8, 11, 9, 13. Then 10th question. 10th question is nothing but prove that angle between the two tangents drawn from an external point. Shall I erase this? Angle between the two tangents means where it is the angle. From an external point, angle between two tangents. This is the angle they are talking about. Okay. Read it out further. Prove that the angle between the tangents drawn from an external point to a circle is supplementary to the angle subtended by the line segment joining the point of contact at the center. Line segment joining point of contact at the center means radius. So these two angles are supplementary, like we have to prove. That is 1 plus 2 is equal to 180 degree we have to prove. Okay. What do you know about this angle? 90 degree. This also 90 degree. And when you see, isn't it that PAOB is a quadrilateral? Use angle sum property of a quadrilateral. When you use angle sum property of a quadrilateral, 360 degree. 1 plus 2 plus 90 plus 90 is equal to 360 degree. 90 plus 90, 290. Yeah. I'll check. 90 plus 90, 180 degree. So 1 plus 2 is equal to 360 minus 180. 360 minus 180 is 160, right? 180. I'll check. Okay. Got it? Any doubts on this? So 8, 11 we finished. 9, 13 we finished. 10 also we finished. Still 12th question alone pending. Am I right? If you are feeling difficulty in mentioning the angle, you can mark the angles as a number 1, 2 and all. Okay. But proper way we should write like name of the angle only. But the diagram should be neat and clear. Okay. Then it is acceptable. And question number 12. Look at the question number 12. There is a in circle. We need to find the radius of the circle, isn't it? And what is given? Here 6, here 8. 6, 8. And then find the sides AB and AC. Side we have to find. Okay, here 6 means here also 6. Here 8 means here also x. We take this is x. Okay. And then we will be dividing this triangle into 3 equal parts. Okay. Find the area of the triangle using Heron's formula. This is fully 14. This is fully x plus 8. This is fully 6 plus x. Then using Heron's formula we can find. What is Heron's formula? You remember? S is equals a plus b plus c by 2. It is square root of s into s minus a. Okay. Then when you substitute this, you may get to an area. And that is also equal to area of these 3 small triangles. Is it? Is it or not? So this is base, this is height. Half into base into height. Radius of the circle, how much they given? 4 centimeter. 4 centimeter, it is given in the question. So, this Heron's formula, here you have to calculate, that is equal to half into base 14 into height 4 plus again half into, for this triangle base is x plus 8 into height again 4, and then for this triangle half into base 6 plus x, height to 4. Okay. And then here using Heron's formula you should write. So square root of s means what? 14 plus 6 plus 8 plus 2x, that is 28 plus x you may get. No, 28 plus x, 28 plus 2x by 2. So it is 14 plus x only, yes. So here 14 plus x, and then s minus a, 4. That is x. Okay. And then s minus a, s minus b means this is a, this is b. Then x will get cancelled. 14 minus 8, 6 only. And then here also 14 plus x minus 6 minus x, plus x minus x gets cancelled. Then here you may get 8 only. Okay. Here also 1 by 2, 4 we can take out as common. Remaining 14 plus 8 plus x plus 6 plus x we may get. And then after that square on both sides, simplify. Okay. You may get your answer. Got it? Or you want me to solve this? Try solving it, come on. Oh, you don't see. Okay. See man, it's really easy. We have 14 plus x, and then into x into 8 into 6, that is equal to half into 4 into 28 plus 2x, and this is simplified as 2, and then this is what, 6 8s are 48 into x into 14 plus x. When you square on both sides, y square, from here take 2 as common, 2 2s are 4, here also you may have 14 plus x, correct? If we take 2 as common, this one, see I added everything. In this 1 by 2, 4 is common, is it? I took 1 by 2 into 4 as common, then remaining, here 14 will be remaining, here x plus 8 will be remaining, here x plus 6 will be remaining. Add everything. 24 plus 2x, sorry 28 plus 2x, is it? Then 28 plus 2x, and then from that I took 2 as common. Already by simplifying this I got 1 2, 2 2s are 4. Now square on both sides. When you square on both sides, 48 into x into 14 plus x equals 4 square, it is 16, and 14 plus x whole square. Okay, just simplify this, and this will get cancelled. Here 48x by 16 equals 14 plus x. How much it is? 3 times, is it? Then 3x equal to 14 plus x. When you transpose here, 2x is equals 14, x is equals 7, but that is not the answer. What is the answer? You have to find the sides AB and AC we have to find. So 8 plus 7, 15 is the length of 6 plus 8. So 6 plus 7, 13 is the length of AC, and AB it's BC I think. BC na, here 15 is the length of therefore the length of the sides AC and BC is 13 and 15 respectively. Like you have to write and finish. Okay. See, circles is a very easy chapter. but you are complicating it. Only 2 exercise. The second exercise, first few questions are very easy, and for the past 5 years they asked only textbook questions, exact textbook question, example or exercise. That alone you have to be aware. That's all. Okay. Then extra we can study the questionnaire. That is enough. Apart from that, don't confuse yourself. Got it? Now questionnaire also, you just study priority 1 and 2. That would be enough. Yes, sir. Yes, tell me. I need to clarify this. Just a minute.